Alright, today we're going to be looking at like terms. So in our table of contents, it is 2 pages, so big 5 on 63 and 64. And we are looking at like terms. Alright, so we're going to turn to page 63. Our page looks like this. So we're going to cut that in half. This is going to go on page 63. That's the first thing we're gluing down. And it's going to be sideways, so it doesn't matter which way you put it. And on page 64 is this page. So I'm going to go ahead and number. This is page 64. And the other page is 63. And the title is like terms. Alright, so let's start out with the definition of like terms. Like terms are terms that contain the same variable raised to the same power. And remember that power is just a fancy word for exponent. So a like term are terms that contain the same variable raised to the same power. So some examples would be n and 3n. They both have the n, so they are like terms. It doesn't matter what their coefficient is. Now I want you to remember, even though this n doesn't have anything in front of it, it has an imaginary 1. So n and 1n are the same thing. We could have n to the 5th power and 5n to the 5th power. Both of the variables are n, and they're both raised to the 5th power. N raised to the 5th power. So those are like terms. More like terms are constants, 12 and 28. Those are both constants, so they're both like terms. We could have 26f to the 6th power and f to the 6th power. Both of them have f to the 6th power, so they are like terms. Another example would be 6x squared and 7x squared. They both have x squared, so they are like terms. So sometimes it helps us to see a non-example. Non-examples would be like x and x squared. Those are not like terms because they're not raised to the same power. You couldn't have f to the 6th power and y to the 6th power. They have to be the same variable. F and y are not the same variable. Also, if you have AB and ABC, those are not like terms. You have to have all three of them. So AB and ABC are not like terms. One that you guys really will struggle with is a constant like 3 and a variable like W. You will always want to say that's 3W, but it's not. 3 is a constant, W is a variable. We cannot combine them. So let's review some of the characteristics. You have to have the same variable. Remember, variable is just a fancy word for letter. The variables must have the same exponent. Or both terms are constants. Okay, let's look at some examples on the next page. The next page says, in the expression above, so 12x plus 7 plus 5x, there are 3 terms. Okay, remember last week we talked about terms are separated by plus, minus, or equal sign. So we've got a term here, a term here, and a term here. Okay, so our terms are 12x, comma 7, comma 5x. The terms with the variable x are like terms. Because they have the same variable raised to the same power. We can combine only like terms. So combine, this word right here, means that we can add them or subtract them. You use the sign in front of each term. Okay. So that's something that's very, very important. I want you to remember, you have to use the term in front, the sign in front of each term. So 12x, that's a positive 12x plus 7. So this plus goes with the 7 because that's what's in front of it. And then we have plus 5x. So that's a positive 5x or plus 5x. Now the two things that we can combine are 12x and 5x. So how do we know if we're adding or subtracting? We're looking at the sign between them. If I were to take out this plus 7, okay, I took it out, that would give me 12x plus 5x. Well, 12 plus 5 is 17x. Okay, so we've used this one. We've used this one. Whatever we have left over goes behind it. So plus 7. So when we had this expression, we combined our like terms to get 17x plus 7. This is our answer. There is nothing else we can do. We cannot combine the 17 and the 7 because they don't have like terms. They are not like terms. 17 has an x, 7 is a constant. Okay, so something that really helps me is to box my like terms and circle my like terms. So let's try that with this first one. We've got x plus 4 plus 2x plus 5. So I see I've got the term x right here and right here. So I'm going to circle that. X and plus 2x. Because remember, we used the sign out front. X does not have a sign, so we know it's just a positive number. Then we have plus 4, so a positive 4 plus 5. Okay, so if we combine x plus 2x, that gives us 3x. Okay, remember that x, even though it doesn't have a coefficient, has the invisible 1. So that would be 1x plus 2x, that gives us 3x. Then you have positive 4 plus 5. Well, that would give us a positive 9. So we're going to put plus 9 because it's a positive 9. Okay, next we have 10x minus 3x plus 7x squared. So we've got two different types of terms. We've got our x's, so 10x and minus 3x. Then we have plus 7x squared. Remember, it's not like these other two because it's raised to the second power. These two are not raised to the second power. So 10x minus 3x. Well, if I had 10 and I took 3 away, that would give me 7x, and it's a positive 7, plus 7x squared. There's nothing to combine with 7x squared, so we just bring it over. Alright, okay, this next one, it accidentally went to 2 lines. I should have fixed that, so I'm sorry about that. We have 5x plus 6y plus 2xy plus 4x minus 2y. Alright, that's a lot. So, I'm going to grab another color so we don't get confused. I'm going to grab 2 colors. Okay, we've got our x's. So we've got 5x plus 4x. Okay, if I wanted to, I could go ahead and combine those two. 5 plus 4 gives me 9x. Then I have my y's, so positive 6y. And then, I wish our minus sign was down here. I'm going to bring it down and scratch this one out. Minus 2y. So 6y minus 2y gives me a positive 4y. And this term right here, this positive 2xy, that is a term all to itself. The x and the y are stuck together, so we cannot combine them with the x's and we cannot combine them with the y's. So we would put plus 2xy y. All right. Next, we have 7t plus 2r minus 3t plus r. Okay, so I know that my 7t minus 3t, those are like terms. And my positive 2r and plus r are like terms. Okay, I should have boxed those in, I'm sorry. I was using a different color, but when I look back at the screen, you can't really tell that this is blue and this is green, so I'm sorry about that. Okay, 7t minus 3t gives us 4t. Then we have a positive 2r and a positive r. Remember, that's like having positive 1r. So 2 plus 1 would give us a positive 3r. Okay, next we have 14 plus 10p minus 12. So we've got constants. Those are only like terms. 14 minus 12 is 2. Plus 10p is the only thing left. So we bring that over. Last one. 8n minus 3t plus 4n plus 9. Okay, so we've got 8n and plus 4n. That would give us 12n. Then we have negative 3t or minus 3t. Negative and minus are the same thing. We don't have anything to combine with that, so we're going to bring over minus 3t. And then we have a constant, positive 9 or plus 9. So we bring that over. Okay, we will have lots of practice on this today on Go Formative. Please ask questions if you need help. I know that this can be a very tricky topic, so if you need help, please ask for help. Okay? You will also find on point 10, nope, I'm sorry, wrong thing, I'm sorry. Okay, that concludes our lesson.